The first alert was quiet. Queue depth above normal. Then 5 minutes later, queue depth critical. Slack started moving. Why is the worker lag increasing? Messages not being processed. Orders stuck in pending. I opened Grafana. Queue depth was climbing steadily. No spikes, just a straight upward line. Then I checked the processing rate. Flat. Almost zero. That's when I realized messages were going in. Nothing was coming out. We were running on AWS, EKS cluster in US East 1, around 70 microservices. Traffic averaged 2,000 requests per second. We used Amazon SQS as our primary queue, decoupling order processing from the API layer. When a user placed an order, it went into SQS. Workers consumed messages, processed payments, updated inventory, sent confirmations. They ran as Kubernetes deployments, auto-scaled based on queue depth and CPU. The database was RDS PostgreSQL. Redis was used for caching and idempotency tracking. The system was designed to handle bursts. Queues gave us a buffer, or at least that was the idea. Users could place orders, no errors at checkout. Everything looked normal from the front end, but confirmations were delayed, sometimes by minutes, then hours. Orders stayed in a pending state. Support started getting tickets. Internally, API services were healthy, no latency issues, no error spikes. But downstream processing had stopped, and the queue kept growing. First thought was worker failure. Maybe pods had crashed. We checked Kubernetes. Workers were running, no restarts. CPU usage was low. That was strange. If the queue was growing, workers should be busy. But they were idle. We checked logs. Workers were polling, receiving messages, then doing nothing. No processing logs, no errors. That didn't make sense. We increased the log level and redeployed one worker. Now we saw it. Messages were being received, but immediately returned to the queue. No processing. We checked SQS metrics. Receive count was increasing. Messages were being retried over and over. We looked at the message content. Nothing unusual. Valid payloads. So why were workers not processing them? Next hypothesis was dependency failure. Maybe workers were failing silently. We traced one message. The worker received it, attempted to process, then failed at a specific step, database write. We checked the database. It was up. Connections were fine. No errors at the DB level. Then we looked at application logs more closely. There was an error, subtle, duplicate key violation. That was interesting. Now we checked idempotency logic. Workers used a Redis key to ensure messages were not processed twice. If a key existed, the message was skipped. That was expected behavior. But here's what was happening. The idempotency key was being set before processing completed. So if processing failed midway, the key remained. On retry, the worker saw the key, assumed the message was already processed, and skipped it, returning it to the queue. Now the message was stuck. It just kept cycling. The root issue was in idempotency handling. We set the key too early, right after receiving the message, instead of after successful processing. When a transient failure occurred during processing, the system marked the message as already handled, but the actual work was incomplete. On retry, the worker skipped it. The message was never processed successfully and never deleted from the queue. Over time, more messages hit the same issue. The queue backed up. Workers appeared idle, but were stuck in a loop. First step was to break the loop. We disabled idempotency checks temporarily, allowed workers to process messages regardless of existing keys. That immediately started draining the queue. Then we fixed the logic, moved idempotency key creation to after successful processing. Ensured keys were only set when work completed. We also added expiration to idempotency keys. Then we deployed the fix. Workers processed messages correctly. Queue depth started dropping, from thousands to hundreds to normal levels. Full recovery took about 2 hours. What failed was not the queue. It was how we handled state around it. We assumed idempotency would protect us, but implemented it incorrectly. Detection was also delayed. We saw queue depth rising, but did not correlate it with processing failure patterns. Workers looked healthy, which misled us. We also did not track the message lifecycle clearly. Receive, process, success, failure. Idempotency must be tied to successful completion. Queues can hide failures. A system can appear healthy while doing no useful work. Observability should include message flow. Retries need safeguards to avoid infinite loops. And finally, correctness matters more than throughput. In the end, the system kept running, but nothing was moving forward.